So sometimes people aren't so comfortable when they hear that you can add up an infinite number of things and get a finite amount. So I just want to give you a very quick, intuitive proof that this can totally happen. And we're going to sum a geometric series and see that it has to be a finite amount. Okay, so here's what we're going to do. We're going to take an interval on the real number line. All right, we're going to take the interval from 0 to 2. All right, the numbers between 0 and 2. Now what I'm going to do is I'm going to start cutting this into halves. All right, so if I cut it into half once, I'm at the number 1. So how far have I gone? I've gone 1. All right, now I'm going to take what's left over between 1 and 2 and cut that in half. That's a half. I'm adding that to 1, so now I'm at 1 plus a half. That's this position here. Now I'm going to cut that in half, so I'm going to put a mark here. Now, how big is this? Well, that's half of a half, that's a quarter. So how far have I gone? I've gone 1 plus a half plus a quarter. Okay, now I'm going to take what's remaining and I'm going to cut that in half. How much is that? Well, that's half of a quarter, that's an eighth. How far have I gone? I've gone 1 plus a half plus a quarter plus an eighth. Okay, and I'm going to cut that in half over here. That's half of an eighth. I've gone 16th more. So now I've gone 1 plus a half plus a quarter plus an eighth plus a 16th. Now you can see what's happening. I keep adding a power of 2 to this. What I'm generating here is I keep adding these up. I'm generating the series from k equals 1, and we'll leave off how far we're going for right now. 1 half to the k minus 1. When k is 1, my first cut, when k is 1, I'm at 1 half to the 1 minus 1. That's 1 half to the 0. I'm at 1. My second cut, when k is 2, I'm at 1 half to the 2 minus 1. I'm adding a half, right? So that's the 1 plus a half. When k is 3, I'm adding 1 plus a half plus a quarter, because 3 minus 1 is 2, and 1 half to the 2 is a quarter. So this sum is giving me how far I've gone on this in this cutting procedure. Now let's think about what happens. As I keep doing this, I keep cutting half of what's left and half of what's left. It is impossible for me to pass the number 2 because I'm always cutting half of what remains between where I am and 2. I can't pass 2. So I know that whatever this sum adds to, even if I sum an infinite amount, it cannot exceed 2. Moreover, if I were to guess that it equaled some value before 2, I would be wrong, because at some point it's going to pass that number. So the only thing that this thing can equal is the number 2. And so we see that an infinite sum of positive quantities can be a finite amount. And in fact, in this particular case, it converges to the number 2. Add up an infinite number of numbers, keep adding these, and you will get to 2.